Algebra 2 skills number 13, polynomial vocabulary. So let's look at all the words associated with polynomials here. First, the definition of polynomial itself. The official definition looks hideous. You've got all these numbers and these variables raised to powers. But what we should focus on, instead of getting too worried about this, is the fact that all our coefficients, these a's, are real numbers, so you're not going to see any complex numbers. But more importantly, all the variable exponents are whole numbers. Whole numbers being 0, 1, 2, 3, etc. So polynomials have whole number variable exponents. So look at some examples of them. So this is a polynomial because your variable exponent, x, is raised to the first power. So if you see the variable but you don't see the exponent, that exponent is 1. Right here we don't see a variable at all. That's understood to be x to the 0 power. So this is x to the first, this is x to the 0, and 1 and 0 are both whole numbers, so we're good. Another example with a 2, a 1, and a 0 being our variable exponents. Here is only 0 because, again, if you don't see the variable at all, it's understood to be 0. And here we have a 1, a 3, a 0, and a 2 as your variable exponents. Now, things that are not polynomials, you don't want x on the bottom of a fraction. That would be x to the negative 1 power. Okay, negative numbers are not whole numbers. This is not a polynomial. Here, x is under a radical. This is actually x to the 1/2 power, which is one of your exponent rules. 1/2 is not a whole number, so we don't want to see x's or variables under radicals. And we also don't want variables being raised to unusual exponents. Pi certainly is not a whole number. Other things that we didn't show on this slide, you don't want x in any kind of special symbol like an absolute value symbol or a greatest integer function symbol or anything like that. Other vocabulary terms associated, you notice the colors here. In red we have the degree. The degree is the highest variable exponent if you have one variable, and you usually have one variable. So our highest exponent, 2, 1, 0. The highest one will be 2. That's called a degree. The leading coefficient is the coefficient of the term of the highest variable exponent. So the 6 is in front of that 2. That's the leading coefficient. Notice leading is not necessarily the largest. So it's not the biggest coefficient. It's the biggest exponent that we're looking for. And the constant term is this 3 right here. We call it the constant term because there's no variable. And regardless of the value of the variable, this term's always 3. Okay. Occasionally you have more than one variable. You don't see this very often, but if you do, you actually add the exponents together, which is, again, is a little bit unusual. Here the degree is 5. We have x and y, two different variables. So this is a degree of 5 on this term, a degree of 3 on this term because of that 1, and then degree of 4. For the entire polynomial, the degree is 5, which is the biggest of the 3. You don't add all the way through. You add one term at a time. Terms, by the way, are separated by minus and plus signs. So this is term 1, term 2, and term 3. Standard form is when you put the terms in order based on their variable exponents. You want to put them in descending order. So this would not be in standard form because we have 0, 2, and 1. That's not in order. We prefer it to be 2, 1, 0. Again, variable exponents are what we're looking for. Notice also that the negative in front of 3x squared must stay in front of 3x squared. Okay, name by number of terms. A lot of vocabulary here. Monomial has one term. Binomial has 2 terms. The prefix bi means 2. Bicycle has 2 wheels. Binocular, 2 lenses, and so forth. Trinomials, 3 terms. So like tricycle, triceratops has 3 horns. If you have more than 3 terms, we get kind of generic with it. We just call it a polynomial with 4 terms or a polynomial with 5 terms and so forth. You might see different variations of that, like 4-termed polynomial and so forth. We also have quite a few names based on degree. Constant, we've already mentioned degree of 0. Linear, degree of 1. You've worked by now with a lot of linear equations. It graphs a line. Quadratic, degree of 2. You've heard that term. That may seem surprising because quad seems like it should go with 4, but this comes from a Latin phrase, quadrus, which means to make square. So quadratic means degree of 2. Cubic, unsurprisingly, degree of 3. When you cube something, you raise it to the 3rd power. Quartic also sounds like 4, so degree of 4. Quintic, degree of 5. We don't have a common term after quintic. You may hear something like 6th degree polynomial and so forth. So let's look at some examples. Example 1, name it. Well, this is a linear binomial. Degree of 1 and 2 terms. Terms, remember, are separated by plus and minus signs. This would be a quartic trinomial. Highest power 4, that's what degree is, and we have 3 terms. Third example, let's look at this polynomial. That's not in standard form, which is fine. It's still a polynomial because it has all whole number variable exponents. So let's put it in standard form. So we rearrange it 3, 2, 1, 0. Notice again the negative stays with the x. Identify by leading coefficient and degree. So leading coefficient is 7. So notice 7 is the leading coefficient. Easy to find if you're in standard form. It's not the biggest coefficient. The degree here is 3, which is the highest exponent. And name it, that's a cubic polynomial with 4 terms. Cubic, highest power 3, and it has 4 terms.